Hello everyone, my name is Isaveearth. I'm back with lecture series on science. Today's topic is going to be finding out the age of the universe. So how do we find out and what are the different cosmological models which are used to determine that? So let's get started. So the first model being used was called CDM, and with this model they found out the age about 14 billion years. But in this model they did not consider in the beginning other stuff in the universe. So basically they looked at that universe is made up of matter, but there's dark matter, there's dark energy, there's radiation like photons and neutrinos and all that stuff. So was not considered fully, and so they came up with a new model called lambda CDM model, and with the help of this they were able to calculate most appropriate age of the universe. So they use different constants, density constants, I would say, density constants, and the symbol of those is like this. So they have, say they considered matter, for example, so they had m, they had density constant r, they had density constant lambda. So different type of constants, and they also looked at other constant like Hubble. So H is Hubble constant and then F is energy constant, and the formula to calculate the age of the universe with knowing all these constant is time equals 1 over h. F is the energy constant, and then all these density constants, so multiplied by all these density constants will give you the age of the universe once you plug in the numbers for each constant. And the age was, the calculated age with this cosmological model was 13.799 plus minus 0.021 10 raised to power 9 billion years. So this is what is the most accepted age of our universe by utilizing the lambda CDM concordance model. This is called lambda CDM concordance model, and this is the most accepted model now, which gives us the age of our universe as 13.799 plus minus 0.021 10 raised to power 9 billion years. So this is what the actual age is. But there are other methods to calculate the age of the universe, because we know by redshift we know that all the galaxies are moving away from each other, and if we calculate the velocity and the speed of these these galaxies in the universe, we can find out the age of the universe also. So there is another formula which is, you can find the time, that means that the total time when the universe was formed equals d over v, and we know Hubble law tells us that the v is equal to Hubble x d. So this is the formula for Hubble law. So when we rearrange and find we can find out with this formula what the age is. So let's see. So say for example we said t equals d over v, for instance, which will be equal here d over, so look at the v now, v has this value, so plug in that value, h x d would equal, so these will cancel out, would equal h 1 over h, and we can now calculate the time by this formula. So this is the age, but how do we find out the number? So when we look at, for example, Hubble constant has a value of 73 kilometers per second MPC. So that's the Hubble constant value. But what is MPC value? So let's find that out. So MPC value is equal to 3.08 multiplied by 10 raised to power 19 kilometers. So we know now what is MPC. Once we know that, then we can go back to our Hubble constant and we plug in the information, which is 73 kilometers per second, MPC. So X here, 1 over MPC divided by 3.08 multiplied by 10 raised to power 19 kilometer. This is going to give us a number. If you calculate, it's going to give you 2.37 10 raised to power 18 1s. So this is the value you're going to get for your H. Once you know that, now you can plug that into our T equation. So 1 over H means we put this value here, 1 over what is the H value? 2.37 multiplied by 10 minus 18, 1s, which is equal to, when you calculate that, it's going to give you 4.22 x 10 raised to power 17, and that is equal to 13.4 billion years. And this is how we can also find out the age of the universe. So there are different methods, but this is very close as well. But this is the most accepted one, which we use to get that number. We use lambda CDM concordance model, and this is how we find out how old our universe is. Thank you for watching.